Perfect. All right. Well, hey, y'all. I guess let's get started. Welcome, everybody, to another webinar hosted by Metaltoad and AWS. Today, we'll be talking about Amazon Textract, what it is, the problems it can solve, and ultimately how Metaltoad and Amazon can help get you going. Covering these topics today will be Senior Solutions Architect from AWS, Prachi Kulkarni, myself. Hi, I'm David Dolan. I am an engineering team lead for Metaltoad. And we may or may not have a director of AWS Alliances here, Stacy, or a CEO, Joaquin, to talk about POC funding. If not, no worries though. I'll be sure to cover those topics at the end. Real quick, just to kind of cover today's agenda, I'll give an intro to Metaltoad and our upcoming events. Then I'll hand things over to Prachi for a Textract overview and maybe some tips. After, I'll steal things back and we can talk about a Textract case study here at Metaltoad. And then we can close out talking about POC funding opportunities in AWS and kind of any final questions. Cool. Hopefully that sounds interesting to everybody. So Metaltoad is a full-service cloud consultancy. As an AWS Advanced Consulting partner, we've worked with many customers like Daimler, Siemens Gamesa, Claviet, just to name a few, solving complex data analytics and ML problems with them. Beyond our data solutions catalog, we also consistently deliver and support consumer-facing applications for industry leaders like the Grammys, DC Comics, Wheel of Fortune, and more. Metaltoad's received awards for being a wonderful place to work, to which I can attest. And I believe the positive experiences internally also makes us a fantastic partner to work with, but I digress there. Before we dive in, let me just take a moment to call out upcoming webinars slated for May 7th. We'll dive into the results of a hackathon that we held this quarter. We'll take a look at how one of our teams built a chatbot in 2 days that we now maintain as an internal tool. Okay, give me just a moment. I'll hand the screen over to Prachi, who's here to cover some vital Textract knowledge and expertise with us.
Thank you. Thanks, David. Let me share my screen. Please let me know once you're able to see my screen.
Awesome. We see it.
Okay. So let's start with some Textract details. Just give me a second. Just give me a second. There's some noise in my where I am. Sorry about that. Let me just go and close the door.
No worries.
Yeah, it's fine. It's good because Zoom, it blocks all the sounds. So it's just,
yeah.
It can be terrible when you're on here.
My apologies. Yeah, I know Zoom blocks the sounds, but just didn't want to take.
Don't worry.
Anyways, so let's start. So this is the typical AWS AI/ML stack, as most of you will probably know, right? From the ML infrastructure, where we are talking about Inferentia, Trainium, to SageMaker, to the AI services. And as we go from bottom to top, the need for ML expertise kind of changes, in the sense the AI services are more ready to use, where you don't need a lot of ML knowledge. You just need to know how to configure the particular service, and that's how and the service will start working for you. So as shown in this slide, the Textract comes as part of these special services for text and documents, and we are going to talk a little bit more about what Textract is. Okay, so let's start with how the documents were processed earlier. As we all know, manually processing documents, we have been doing that for a while. Obviously not a very good thing to do. It does not scale well. OCR has been around for quite a while now, in fact, a couple of years where we are using OCR. But the problem with OCR is it does extract text very well, but it does not showcase it in a good format, say the key value pair or any such. And also the further aspects that Textract provides as to how you can query the data, etc., all that could not be done with the legacy OCR systems. The third way, which was quite popular at a point, was the rule-based thing, whereby you get the legacy OCR output, the text, and you kind of put it through the rule-based engine. And yes, that works for a while, but as the documents change versions, documents change format, this kind of becomes a difficult thing to scale. And this is where we enter with the service called Textract. Textract is based on OCR, yes, but it goes beyond the OCR with, and it provides excellent accuracy, especially in cases where documents, it has been observed in multiple use cases that we get more than 95% accuracy for the Textract text extraction. It is obviously versatile information extraction in the sense it doesn't, it supports a lot of document types and images types. There is absolutely no ML experience required with respect to the training and deployment and all of that of ML models. Like I explained earlier, it is a ready-to-use service provided by AWS. It results in definitely showing the outcomes to the users faster because a lot of human intervention or a lot of manual aspects of the data handling, of the document handling are removed. And yes, in the beginning, Textract will cost you in the sense it's if you compare it with the manual, say, for example, manual method of document processing, Textract, obviously, since it is a software service, it will cost you. But it has been observed that in the long run, with the number of documents it processes and the less human intervention required, a lot less human intervention, in fact, required, it overall reduces the total cost of document processing. In fact, Amazon Textract has been a part of the Intelligent Document Processing IDP offering of AWS along with Comprehend. And it has been very widely used as Textract alone or as part of IDP by multiple customers at AWS. I'm going to go to the Textract features, and please feel free to stop me right now during the presentation if you have any questions, or we can also do the questions towards the end. So coming to Textract features, there are the typical text extraction features that most of us are aware. But in addition to that, we also support handwriting, whereby we can look at signatures, we can look at text written by hand and kind of make sense out of it. We also have APIs that can handle specialized documents. So say, for example, this is, say, if it is like a invoice that you are looking at, or if it is an ID that you are looking at, there are specialized APIs called Analyze Expense, Analyze ID, those kind of things. There is some comment in the chat. I'm not able to see the chat. So Natalie and or David, if you can take a look at the chat and stop me if there is any question. Okay. So continuing the presentation, those specialized documents, there are APIs handled, provided by Textract to handle these specialized document types. This is in addition to the table processing and the forms processing that Textract allows. And then last year, we came up with a new feature called queries, where, as I mentioned before, it doesn't just stop at getting the text out in a key values pair format. It also lets you have natural language queries sent to the document, sent to the Textract, and it will provide you answers understanding the natural language queries. That's kind of the GenAI aspect of the whole thing. Going to go into a little bit of details as to how this works with specific use cases, say, for example, for text extraction. It is a functionality. It results in, it returns results in 3 blocks. It is typically page, line, and word. There is a bounding box, which is going to surround, it will serve as a useful clue when you are looking at what the test results have been there. Typical use cases are like, for example, the legal contracts or any documents which need a lot of OCR accuracy. This, as well as all the other Textract outputs, come with confidence scores. And looking at the confidence scores, the user can make sure whether things are working right, or if the confidence score is low, maybe it could be sent to further human review, etc. So this is about the documents. Next come the tables. Similar to documents for table extraction, it provides all the relationships you need to understand in the tabular data. For example, the table output will be, again, the page, table, and the cell. This is useful for documents that are largely composed of structured data, like say financial reports or medical records, and which have column names and row names and all of that. And such information along with the confidence score is written when you send that table as an input to the Textract. Same way, there is forms. Textract provides all the relationships that you need. It recognizes the key value pair. For example, in this example, which is outlined here, the first name John, middle name X, and last name Doe is kind of outlined as a key value pair in the output. Similarly, the DOB and the date of birth and the gender information is also outlined there. And this key value pair kind of makes it easy to interpret. As long as you get the values in key value pairs, you can do further lot many things with that information that you're getting. Okay. Just goes a little bit more beyond where it is going to look at invoices and receipts. The catch here is invoices and receipts are obviously not in standard format. And as shown here in this example, the Whole Foods receipt, it's pretty crumpled down as well, which is usually the case. So the Analyze Expense API that can take this type of input, the receipts input. This is an API which is going to give you all the output, all the text from the receipt as again a key value pair. For example, the vendor name, the subtotal, vendor name Whole Foods, and subtotal and net sales and all of that. It will also give you the line items like the pizza slice, price 350, etc. And then going further, when we are going to look at the queries, you can obviously look at the queries, look at this data from the query perspective as well. Typical use cases here, say looking at the account payables, or if there's a rebate, or if there is a trend modeling which is needed, which needs all this type of data, which is going to sit in various formats of documents like receipts and invoices and all of that. This is going to be a really useful way to extract the information. Same goes with the ID. Analyze ID is a specialized API for this specialized document support. Again, ID comes in various formats. It can change by country. It can change by age. Below 18, the driver's license has a different aspect ratio. It's kind of vertical in United States. So typically, the Analyze ID API is going to extract data from the licenses or from the ID documents. And again, here the accuracy is very high. The P90 accuracy is less than 2 seconds. It is almost real time. As soon as you put in the IDs there, Textract is going to use its machine learning algorithms to kind of get the information for you. Typical use cases, again, billing, online registration, and obviously ID verification, and other use cases where you need ID verification done. So here are some of the use cases that I outlined, which brings me to the Textract queries, which is a feature that we released last year. Why stop at kind of just getting the text information? Why not put a support of natural language query processing, query answers to the data which is there? So say, for example, as you can see, the left-hand side here is a typical pay stub for an employee called John Stiles from any company. And the questions are like, what is the year-to-date gross pay? And it is kind of going to provide you the right answers. How does Textract do that? It has a pre-trained out-of-the-box feature which provides customers the flexibility to specify and extract the data they need without worrying about the structure of the data. It is trained on a various variety of data, which is semi-structured and unstructured documents as well. And these documents are obviously used in verticals like, say, insurance and lending and all of that, in addition to all these typical documents like the pay stubs and all of that, W-2s and insurance cards and all of this. It combines visual, spatial, and textual cues to provide higher accuracy. It provides simple Q&A response to reduce the post-processing, and it extracts only the specific fields that matter. It obviously is integrated with the Analyze Document API, which is the typical Textract API, and queries is kind of becomes an extension of this. There may be some limits associated with the queries because there may be some per page query limits which are there, and you might want to take a look at these limits before you start using it. For example, there might be, if you need 30 or more data points from page via queries from a single page, then maybe it could take, they can run into, they can run the pages multiple times. If these pages are going to be running multiple times, then you might want to take a look at the limits of the queries that are there. One more example here. Again, I'm showing this example just because, as you see, the question is, what is the borrower's date of birth? And whereas the date of birth outlined here says DOB, essentially the DOB is date of birth is what Textract ML algorithm is kind of making that connection on its own, and it is going through. One more example of Textract queries, and this brings me to the Textract custom queries. Of course, the custom queries are the queries which are a little bit more beyond the pre-trained queries. If the pre-trained queries are not giving you the outputs which are expected for your use case, you can create and train the Textract ML model to kind of sort of work with your own data. We call it the adapter, and you can create an adapter with an auto update because so the adapter also updates whenever the Textract underlying model updates. And you can put the data set, you can create the queries, you can annotate the documents, test and train. Of course, the training of the model with your custom data for handling custom queries is done behind the scenes by Textract, but you will have to provide all this input. Two ways of processing Textract. One is synchronous processing, another is asynchronous processing. Synchronous processing is near real time, single pager documents, small documents, but our use cases many times consist of tons of documents which are multi-pagers. So the asynchronous processing. The asynchronous processing is going to make use of some other APIs which are going to collectively let you know about the status of the Textract job. And it will also typically in a workflow, it will use the simple notification service, the SNSs and SQSs to kind of notify you when the details are available with the Textract job done. And the results are ready for us to take a look at. So asynchronous processing is going to use a little bit of more workflow and all these other elements, maybe sometimes lambdas as well. All of this is going to be useful to handle multiple documents, multi-pager documents, etc. Which brings me to the last section of my presentation, the best practices. Textract ultimately is a machine learning algorithm, and so it is going to work. It in fact provides excellent accuracy with handling most of the text, but still, for better results, if you observe these, say, for example, the documents are in the language that are supported. There is a list of languages on our website. The image quality is at least 150 dpi if Textract is to kind of make sense of the images. If the document is already an image which is supported, you don't have to convert it to or downsample it to a document away from the image format and then upload. You don't do that because it's kind of going to impair the accuracy. Same way, look at the confidence score. You can apply threshold that if my confidence score is, say, below 60%, then I want to kind of automatically put it for human loop review, and that kind of automates the whole thing and minimizing the intervention by humans. It is only done as and when necessary. Same way for query break practices, use table rows and columns, avoid long answers. Can it give you long answers? Yes, but the queries are more designed towards looking at the documents and giving you answers for specific table row column headers related information. So it works best that way. Can it still give you long answers? Yes, it can, but you can try and look at the accuracy that it is going to give you, because ultimately it is the generative AI aspect that it is going to use here. Same way, throttling, if there are large number of simultaneous transactions, throttling can happen. You can configure retries and all of that to handle the throttling. We talked about the custom queries, data sets, how to specify the data sets and all of these. These best practices are also available somewhere on the Textract website. At least some of them, most of them are there available on the Textract website by AWS, and you can take a look at that. And yeah, that brings me to the end of my section where I was supposed to give you the overview of Textract, and I will be handing it over to David to discuss the case study.
Awesome. Thank you so much, Prachi. That was amazing. All right, let me steal screen back. Let's see. Hopefully we're looking at a case studies slide.
Yeah.
Awesome. All right, so let's talk about an actual case study that Metaltoad has applied Textract on. We'll take a look at the solution that we found for one of our clients, PRCO. Just a little background, PRCO is an auto claims handler dealing in things like insurance and repair claims. They handle contracts in volume, and therein lies the problem that we kind of help solve. So as I mentioned, PRCO handles lots of contracts, specifically paper contracts, actually. These are ultimately scanned and exist in a system as PDFs upstream. So outside of our project scope really begins when the PDFs come to rest. So these PDF files contain many pages, not uncommon for a single PDF of theirs to have 50 plus pages, let's say. So their problem actually looks more like this. We have lots of PDFs, possibly in a continuous stream at times, that require processing, each one with lots of pages. Rather than, say, looking for a needle in the haystack, we actually need to sift through all the hay straws, figure out what type of hay it is, and then grab the serial number written on each straw. I probably took that metaphor too far, but that's kind of the idea. So as we saw it, if we plan to take this thing kind of page by page, PRCO really just needs 3 things per. First, we identify if the page is junk. Like most pipelines where humans can toss things into it, we expect a certain amount of sanitization is going to be necessary. Then if the page is not junk or noise, we need to parse out the document ID, and we'll have to identify which of the 3 possible contract types this document is. We know from the client we're looking for VSC, GAP, or TWP. And I'll be totally honest with you, while I am familiar with gap insurance on cars, and if you're not, that's probably good. But if you're not entirely sure what VSC and TWP are, that's fine. I have no idea either. So, okay, let's take a look at how we solve this for our client by orchestrating Textract and all the downstream ETL stuff into a step function. Starting at the top, outside of the state machine, we have an S3 bucket that kind of serves as our trigger for the step function. When a new PDF gets dropped into this bucket, it kicks off a run of the pipeline and feeds the S3 file prefix into the step functions event. Should be no surprise. Step 1 is to start a document text extraction job in Textract. And as Prachi's called out, that's not the only approach that you can take in Textract to find your areas of interest. We actually initially just lean on looking for lines and words, but we also do use queries. We leverage both of those in this solution. At this step, however, we just leverage looking for lines and word blocks, as queries do kind of come with an extra cost. And so we start there. To understand the way in which we kind of use queries, let's take a look at what we do in this step first. On the left, we have our example contract as a PDF. In the upper right-hand corner, you can see is our area of interest. This is where we gather the type of contract and the ID. When Textract parses this for us, we get a list containing JSON that tells us what Textract thinks the block is, the location on the page as the bounding boxes, and the confidence score in that. This score is ultimately what we're going to use downstream to determine if the initial Textract job was good enough for us. Next, since we're analyzing a bunch of pages, this Textract job is best returned asynchronously. So we just kind of enter a polling loop where we check for the current job's completion every 30 seconds here. And that may have been changed or optimized, but that's what I had when I looked. Our polling state change step sees when the job status is changed. So when it's changed to succeeded, then we're able to move on to our Textract processing Lambda. This Lambda is where we open up our Textract job and transform the output into a list of pages. So let's just we can scan some of the code that's in there. Just taking a real quick look, you can see at the top, we're using regular expressions to ensure the types and IDs that we get fit the expected format. We define our coordinate threshold, which gives us a location where we're expecting to find the identifiable information. Further down, you can see some things about tokens. This is us actually just handling pagination coming from Textract. So I apologize, it is pages of pages, which can get a little confusing, but it is what it is. And then we enter our for loop, which is where we build our formatted output to feed into our final steps, a little ETL, I suppose. And this is actually, you can see where we're using the regular expressions defined above. If we back out, and I apologize, we're going quickly. I know we're kind of up against the time here. The input event here is just the job ID, really. Ultimately, when we are inside of our Python code, we leverage Boto3 to pull all of the relevant information from that job. So that happens inside the Lambda. On the right, you can see the output step from that Lambda, which we return a page number, contract type, contract ID, and Textract's confidence in these results. Then our final block of steps here, we check to see if there's any contracts present in the list. If this is not the case, we send this off to SNS to notify an admin that we have a run for review. If we do have contracts in the list like we saw in the last slide, we review the results, checking if each page confidence score meets our threshold. If the confidence score for any given page doesn't meet our threshold, that's when we kick the page back into Textract again, single page this time, to do a query to see if we can't find our fields of interest. If that doesn't hit our confidence score that we expect, this page then gets flagged for human review too. So lastly, we push everything into the client's API, which is with all the extracted metadata, making their contract pages searchable, sortable, all the above. So really quick recap, we get large stacks of contracts in the form of PDFs with many pages. We then use Textract detect jobs to scan the entire PDF. After we do some ETL, notification, error handling, then if the confidence score isn't what we expect from our initial job, we send this back to Textract again and try with a query job. And then finally, if that page doesn't meet our confidence threshold, we send it for review by a human. All right, really quick, let me get into, let's talk about funding opportunities with AWS and Metaltoad. I just want to call out, we've built similar ML and ETL pipelines to what I just showed as POCs for clients and helped those clients navigate AWS funding. So what does that really look like? What is a POC? Proof of concepts are small scale projects for customers looking to explore AWS workloads. The POC is meant to determine the feasibility of AWS as a solution and verify functionality as is expected. AWS, of course, offers funding because if success is found, Amazon will expect your business. How do you qualify? First, you must work with an AWS partner, like Metaltoad. For said partner to qualify, they must be validated or in a higher stage than validation in their partner path, and that path must apply to the POC. I do want to call out Metaltoad is both a software and services partner. The available funding is as follows. It's up to 10% of first year annual recurring revenue or the annualized spend with AWS. That's what can be made available. This is limited to a max of 25K. However, I'd be remiss if I didn't say there's other projects in place, or other programs rather in place if you need higher spends. Please note that projects need to be paid out at completion, but credits are issued up front, and know that the process does require pre-approval, and in our experience, that can take a few weeks. I'm not sure if we've got any
Yes, we do,
questions.
David. Nathan is asking, how does Textract do with O's and zeros? Are there any other characters there that it has issues with?
That is an age-old problem with OCR. As you can imagine, O's and zeros do look very similar. Depending on the font too, that challenge can get even worse. Yes, we have run into the O versus zero problem, specifically on PRCO. I actually think that was a project that we ran into that. Yeah, I think our solution is you got to try different routes, and ultimately, I think our real final solution was feedback with the client. So it is a difficult one. It's one that I think a lot of teams run into, and there's not always a very clear path around it. I'm not sure, Prachi, if you have anything to say.
It's the same thing. It's basically a ML model. So, and it is going to be kind of suffering from some of the limitations of OCR, like you rightly said. Maybe the human in loop where you can keep on giving feedback about certain things which are wrong in some way can help it, like you said, or maybe kind of approach the client about, yeah. And other than zero and O, I don't know if there are any such cases, but one thing I can think of is S and 5 or maybe something like that. I don't know. I mean, But yeah, people are always working on kind of fixing this problem, but whether this is fixed once and for all, I don't think so as yet.
Yes.
Yeah.
Yeah, no, of course. No, if you have any control over the data set or the IDs or the things that you're actually trying to extract, simple rule is you don't have zeros where you can have O's or vice versa. But yeah, there's certainly cases where you don't get that choice and it becomes a pain point. Yeah, do we have any other questions?
All right. No, not so far.
Okay.
And we are a little bit over time, so
Okay,
I think it's fine.
yeah, since we're over, let me just leave us here.
Exactly.
So thank you so much for attending, everybody. Please, if you have further questions or are interested in how Metaltoad and AWS might assist you with your Textract problems or larger ETL projects, feel free to give Stacy an email at stacy.gordon@metaltoad.com. She's wonderful, knowledgeable, and happy to help get you started.
Exactly.
Thank
Thank you
you.
so
Thank you,
much,
everybody.
David and Prachi. It was an
Thank you.
awesome webinar.
Thank
Thank
you
you,
too.
everybody who
It was a
attended.
pleasure.